Hello and welcome back to the linear algebra component of the calculus and linear algebra series. In the last video I gave a brief introduction to some of the topics that are going to be covered throughout the semester of this course, and in this video what we're hoping to do is we're hoping to introduce the idea of something called propositional logic, and that is going to be based around this idea of something called propositions. So our natural starting point is to introduce what a proposition is. So let's go to our definition here and look at what the definition of a proposition is. It's also sometimes written as a statement. So a statement or proposition is a declarative sentence that must be either true or false. So a simple example of something that could be like a proposition could be something like my name is James. That's an example of a proposition, as it is a declarative sentence, and in this case it is true. And there's a neat way to be able to check whether or not a sentence you've been given is indeed a proposition. And the way to do that is to put the words, is it true that in front of the sentence? And if this new sentence makes sense and a truth value can be determined, then the original sentence was indeed a proposition. And this might seem a bit complicated or a lot of waffle at this point, but we'll see this is very natural by just looking at a couple of examples in just a moment. So let's see if we can use this test on a couple of example propositions I give you here. So the first example I'm going to give you is 2 is an integer. So let's see if this passes our test. We put the words is it true in front of 2 is an integer and see if that new sentence makes sense. So is it true 2 is an integer? That sentence does indeed make sense. And now we need to check if that sentence has a truth value, and it can be determined. Indeed, it has a truth value. In this case, it is true, so we can determine that truth value. The second one we're going to take is another simple example, something like Paris is the capital city of France. Again, we put is it true that in front and see if that sentence makes sense. So is it true that Paris is the capital city of France? We can see that that sentence does make sense, and a truth value can be determined. Once again, in this case, it is true, so it indeed is a proposition. The third one is a little different. We've got the earth is flat. Now we can use our test again, which is it true that the earth is flat? Does that sentence make sense? Indeed, it does make sense. And now we need to determine a truth value. Now, depending on what circles you mix in, or whether or not you believe in circles at all, you might say that this is true, or you might say that it's false. But it's not really the point here of whether or not you'd say it's true or false. The point is it always has a truth value, and someone would always say that this is either true or false. So indeed it passes both of our tests, and therefore it is a proposition. So let's look at some examples that aren't propositions, because it might seem that everything is a proposition at this point. So here's a sentence that is not a proposition. I could just say something like hello. It's non-declarative, and it also doesn't pass my test, right? If I put is it true in front, is it true hello? Does that make sense? That doesn't make sense, therefore it's not a proposition. Similarly, I could say, is it raining cats and dogs? So this is just a question. And if I say, is it true, is it raining cats and dogs? Does that sentence make sense? No, it doesn't. Therefore, it's not a proposition. In fact, this one's a bit subtle, because if we flipped around is and it, and we said, it is raining cats and dogs, and removed the question mark, that in fact would be a proposition. So this one's a little subtle. And the third one is a weird example, because let's check. So if we do our is it true test, we do is it true P is a prime number? That sentence does make sense. But now we need to go to our second test, and we need to say, can a truth value be determined? Well, I can't determine whether or not this is true or not, because I don't know what P is, right? P could be 2, 4, 5, 7. It could in fact be any object at all. It could be a cat, dog, piece of cheese, Boris Johnson, whatever you want. The point is, because I don't know what P is, I can't actually determine if this thing is true or not, and therefore it is not a proposition, so it fails on our second point of the test. And in fact, this is something that is otherwise known as a predicate. And that's something that we'll cover later on in the course when we come to first order logic, and we're kind of touching on a point here about where propositional logic fails, and we actually need a higher order level of logic in order to deal with sentences of this type. So before I move to any more definitions, what I want to do is I want for you to try some questions yourself. So I've brought a question up here, and I want you to use the test that I've just introduced. Is it true, that test? And also to check whether or not you can determine a truth value, to see if the following sentences, if any, are indeed propositions. So I want you to use our test, which is to put is it true that in front, and then see if that makes sense, that new sentence. And after that, see if a truth value can be determined. And if it passes both those tests, then that original sentence was a proposition. So I want you to stop the video now, have a go at this question, and then come back and we'll go through the solution. So hopefully you've tried that now, and I will reveal the solution over here. And we see that the solutions are C and E, and we'll go through them all individually and see where each of these sentences fail our test. So if you look at A, we could say, look over there. Well, is it true, look over there? Does that make sense? No, it doesn't. So it's not a proposition. Is it true, welcome to this video lecture? That is not a sentence that makes sense, so it is not a proposition. Is it true that Justin Bieber is the greatest songwriter that has ever lived? That is a sentence that makes sense, and we need to see if it has a truth value. Well, I have no idea whether or not some people will say this is true or not, but definitely people will say that this is, I would like to think, false, but many people may also say that this is true. So indeed, this passes both our tests and it is a proposition. So let's look at D. Well, D is our little tricky one if you haven't noticed. If I do, is it true that n is an integer? That does make sense. But I can't determine a truth value again because I don't know what values n can take. It could take anything, and therefore I can't actually determine its truth value. So this is another example of something that I called a predicate. E, the moon is made of cheese. Is it true that the moon is made of cheese? That is a sentence that makes sense. And I can determine a truth value. I guess most people would say this is false unless you religiously follow the teachings of Wallace and Gromit, and then you may say that it is true. And obviously it is an F, because we've already deduced that two of them are in fact propositions. So before we move forward and introduce our final definition of this video lecture, what I want to do is I want to talk about what is the task of propositional logic. And firstly, I want to say that it is not the task of propositional logic to determine whether or not a particular proposition is true or not. And we've kind of seen that with some examples here, where some propositions were true for some people and false for others, but it didn't really matter. That wasn't really the point of propositional logic. It was just that it took the value of true or false. So that's the first point. And the second point is that it is also not the task of propositional logic to deduce whether or not a particular sentence is in fact a proposition. And this might seem massively contradictory given that we've just spent the past couple of minutes trying to motivate, how to find propositions from certain sentences. And in fact, what it is the case, or what is the purpose of propositional logic is to build a logic-based system around this basis of propositions. So we introduced this example of kind of propositions at the beginning, and what we want to do now is much like if you would introduce numbers in school and then you start talking about variables. So these are kind of things that take values from that space of numbers. In this case now, we want to take variables that take values in the space of propositions. So the reason why we introduce these examples at the beginning is much like you start with numbers in school. You first start learning about numbers, then you learn about variables. And in this situation, we've introduced what a proposition is, and now we're going to generalize it by looking at things called propositional variables. Those are variables that run over the space of propositions. And it is the task of propositional logic to build a logic-based system around those propositional variables. So let's introduce our final definition of this video, namely that of a propositional variable. And as you might expect, the definition of a propositional variable is a variable that takes values of either true or false. So it's effectively just a variable that can only take in propositions as its input. So it runs over the space of propositions. And this might seem rather abstract, but it's no more abstract than saying x and y runs over the space of numbers. Instead of running over numbers now, we're running over propositions. And much like, again, x and y has a standard notation that you used in school, in propositional logic we have a standard notation for a propositional variable, at least for this course, and we will use a capital P in general or capital Q to denote a propositional variable. So at this point, I think that's where I'm going to conclude the video. And in the next video, what we're going to talk about is we're going to talk about how we can connect two propositional variables and map them to a new propositional variable as well as how to take a single propositional variable and map that to another single propositional variable. And this is going to introduce the concept of something called a logical connective or logical operator. So thank you very much for watching the video. Do remember that there's notes on the Moodle page for you to read afterwards, and I will see you in the next video, and thank you very much for watching. Bye.